A knife edge of steel is the only thing preventing 10,000 tons of kinetic energy from turning into a pile of scrap metal. You're looking at a railroad switch, a mechanical paradox where massive infrastructure must move with the precision of a surgeon's scalpel. At its tip, the switchblade is ground down to a literal sliver to ensure the wheel flange never catches the edge. But how does this thin piece of metal survive the crushing weight of a heavy-haul freighter without snapping? The secret lies in graduated risers. The switchblade actually sits slightly higher than the main rail. As the train enters, the load is handed off from the main track to the blade, only when the steel is thick enough to hold it. If that handoff fails by even a quarter inch, the wheel flange picks the switch, and the train splits in two. To prevent this, a pneumatic switch machine slams these rails into place with 5 tons of force in under 1 second. Then, a mechanical plunger locks the assembly, making it part of the earth itself, immovable under the lateral thrust. But the blade isn't the only genius here. Look at the wheels. Train wheels aren't flat cylinders. They are conical, shaped like subtle ice cream cones. This conical geometry allows the train to steer itself through the curve using pure physics, not just friction. On a turn, the outer wheel rides on its larger diameter, covering more ground than the inner wheel automatically. It's a self-correcting pendulum that fights to stay centered at 60 miles per hour. But wait, there's a fatal flaw in the system: the frog. Usually, there's a physical gap in the rails where 2 tracks cross, causing a massive jump impact. For 10,000-ton loads, this impact would shatter the steel in days. The high-speed solution: a swing nose frog, a secret intersection that physically moves to close the gap. It creates a continuous, solid path of steel, eliminating the jump and the danger entirely. This mechanical choreography is the invisible backbone of global logistics. Subscribe to see more of the hidden world that moves our planet, because